All, Vinod here from Entrance Engineering Academy. Before going into the video, I just want to say a few things about Entrance Engineering Academy. So, EEA is an online gate preparation portal, and we offer full course for GATE ME and XE. In addition to that, subject courses are also available for ME, XE, CE, and PI. Engineering mathematics course is available for all stream, and in addition to that, we offer online test series for GATE ME and XE also. So this is our website. You can just check out so that you will get to know more about us. And in addition, we have our own Android app and also iOS app, and you can just go through that also to know more about our courses. Okay. And this is our last year, that is GATE 2021 result from XE. And now let us proceed to the video. And this video is taken from online video course of Endurance Engineering Academy. So let us discuss a problem based on Euler's approach, that is based on polar coordinate system. So yeah, so the position vector OP vector of a point P 2 comma 10. Okay, so this point P which is given is 20 comma 10 is rotated anti-clockwise in xy plane. So this is the xy plane and this is rotated in anti-clockwise direction by an angle of 30 degree. So this theta is given as 30 degree such that point P occupies a position Q. So initially this is point P, now it is occupying new position which is Q as shown in the figure. The coordinate x comma y of Q are dash, that's what they are asking. So they are asking about this coordinate. Okay, let us take it as x1 comma y1. So ultimately we need to find out this x1 comma y1. So how can I find it? It's very simple. In fact, if I know this total angle, okay, if I know this total angle, I can easily find out x1 and also y1. Am I right? So ultimately we need to find out this total angle. We know theta, but we don't know this angle, right? So how to find out that angle? That is also in fact simple. We will take that to be alpha, okay, that to be alpha. See, this point P, okay, this particular point P, this distance will be what? Let us take this distance is going to be 20 comma 10, right? So this distance is going to be 20. Let me erase this for as of now. I will erase it. Okay, now you could clearly see this triangle O P, and let me take this as OPQR, right? Okay, OPR, let it be. So in this triangle OPR, this is angle alpha. This distance is 20. And what about this distance? What about this distance? It's going to be 10 because 20 comma 10. So x-axis 20, y-axis 10. So tan alpha is going to be opposite, which is 10, by adjacent, which is 20. So which implies alpha is going to be equal to tan inverse of 10 by 20, which is tan inverse of 1 by 2. So from this I can find out alpha. Let me give you the value later. You can use your calculator for finding out also. Okay, right? So we determined alpha. So this total angle is going to be theta plus alpha, right? Let me draw the diagram again here. Okay, so this is y-axis, this is x-axis, this is our q. Okay, so this angle is going to be theta plus alpha. Okay, so theta is 30 degree, alpha I can determine from here. Now what about this length OQ? Simply OP will be equal to OQ only. I'm just rotating this line. I'm just rotating the line, right? I'm not elongating this line or I'm not compressing this line. So this distance OP will be equal to OQ also. Okay, so as a distance OP and OQ will be same, but the angle is changing so that the coordinates will also change. Now how to find out OP? Again simple, from this triangle OPR. Okay, from this triangle, hypotenuse square is equal to adjacent square plus opposite square. So OP, let me take it as R, okay, let me take it as R. Okay, so OP, which is equal to R, which is equal to root of adjacent square plus opposite square, so 20 square plus 10 square. So which is nothing but root of 500, right? Am I right? Yeah, so 500 means 5 into 100, so I can write it as 10 root 5. Okay, so R is going to be 10 root 5. So simply this distance OQ is going to be 10 root 5. So alpha, so tan inverse of 1 by 2, you will be getting 26.56. Okay, 26.56. Alpha will be 26.56. Already this is 30, so 30 plus 26.56, it is going to be 50. It's going to be 56.56. Now how to find out coordinate? Simple. This is x1 comma y1, right? So this distance is x1, this distance is y1. So x1 is nothing but 10 root 5 cos, okay, 10 root 5 cos, because I'm resolving in the angle known side. As I already discussed this, I already made a video on this regarding the resolving of vectors, which is there in our basic video lecture, okay. So 10 root 5 cos, okay, so x1 is equal to 10 root 5 cos of 56.56 and y1 is equal to sine, because I am resolving vertically, right? I am resolving vertically. So 10 root 5 sine 56.56. Okay, so angle known side, angle known, this is angle known. So if I resolve an angle known side, it will be cos. This is unknown. So angle unknown side, vertically, if I resolve, it's going to be sine. So finally, if I solve this, x1 I will be getting 12.32 and y1 I will be getting 18.659. So the final answer was 12.32 comma 18.659. So the result was option C. Very easy question based on polar coordinate system. So let us do the next question. So the question is displayed in the board. Just try to read the question and try to solve it. It is also previous year GATE question. Okay. Right, let me explain. You pause the video, try to solve it. If you are not able to do, then you just play the video. I will explain it. Okay. So now, very simple and what I could say, a very good question. What does this question says? Let us understand. They given that there is a triangle like this PQR and the coordinates of the triangle is also given. Okay. And they are saying that this triangle is being rotated in XY plane in clockwise direction at an angle theta. Okay, at an angle theta in clockwise direction. So this is the triangle and this triangle is rotated in this direction, okay, in clockwise direction by an angle theta. Okay, and for finding out theta, they given sin theta and cos theta. If I take sin inverse, I can find out theta, straightforward one. But the problem here is, first we need to find out what is the angle it is inclined initially. Then only I can proceed, then only I can find out the new coordinate of z, new coordinate of q. This is q, right? So we need to find out what is the new coordinate of q. So how I am going to solve? First let me find out what is the angle at which this PQ is inclined initially. Okay, what is the angle at which this PQ is inclined initially? Then I will rotate it and I will find out what is the new angle, and based on that I can find out the new coordinates. So what I'm going to do, I'm going to assume a new what I could say reference line, okay, which is passing through P. New reference lines which is passing through P. Let us take it as y dash and let us take this as x dash, and let us take angle between this new reference axis, that is x dash, and PQ, okay, as alpha. Okay, this is theta, right? So this angle is alpha. Now I am rotating this PQ at an angle theta. Okay, so at an angle theta. Now listen carefully. If I rotate this PQ at an angle theta, it can be rotated, maybe this can be rotated until this straight line exactly, or before this or after this also. So I don't know what is theta exactly. Okay, as of now I don't know what is theta. Okay, as of now I don't know theta, what is theta. But listen carefully, this line PQ, if I rotate it by an angle theta, it can reach here, it can reach here, or it can be here, or it can be here. So totally 3 possibilities there, and that is completely depends on this alpha value and theta value. If theta is greater than alpha, okay, if theta is greater than alpha, then my new PQ will be like this. Okay, if theta is lesser than alpha, then my new PQ will be like this. If theta is equal to alpha, then exactly horizontal. Okay, so that is what we need to find out. So first we will try to find out this q, first let us try to find out this alpha. Once if I know alpha, then I can easily find out how does my new PQ lies, and then we can find out the coordinates. Okay, now how to find out alpha? Let us see. If you observe properly, this alpha can be determined by using these two coordinates. Okay, so this alpha is nothing but what? Let me just do this thing to you. In the last case, what I did, tan alpha was equal to opposite by adjacent, right? Tan alpha is equal to opposite by adjacent, and yeah, tan alpha is equal to opposite by adjacent. Now also the same logic only. I will just draw a dotted line here. This is going to be my opposite, right? This is going to be my opposite. This total is going to be my opposite, and adjacent is this total. Okay. So now what about this distance, opposite distance? Simply this total distance was 5. Am I right? This total distance from our basic reference line, the distance is 5. And what about this distance? What about this distance? Simply P was present at a distance 3, right, from the ground. So this is going to be 3. So this total is 5. This is 3. Then what will be this? Let me take this as to be some A. Okay. So AQ is going to be, total is 5. 5 minus 3, which is going to be 2. Now similarly, what about this distance? PA. This is 1. Okay. This is 1. This distance is 1, right? And what about this distance from origin, that is from y-axis to this distance, this total distance, this point Q is present at a distance of 4, right? So this is going to be 4. So this is 4, this is 1. So this is going to be 4 minus 1, which is 3. So now apply tan alpha for this triangle. What triangle? AQP. Okay, for the triangle AQP. So tan alpha, okay, will be equal to opposite by adjacent. Opposite is QA, which is 2, by adjacent is PA, which is 3. So alpha is equal to tan inverse of 2 by 3, which is equal to, let me check the answer, which is 33.69. Okay. Now alpha is 33.69. Okay, so I need to find out the remaining two things also. The one is I need to find out what is this distance PQ. How to find out the distance PQ? Simply use the length of the line formula. What is the length of the line formula? I just need to find out the length of this line, right? PQ line. So PQ is a line. So PQ is going to be root of x2 minus x1 whole square plus y2 minus y1 whole square. I hope you know this. Simply length of the line formula. Initially this point was here at 0, 0, but now this is here, that is at some other coordinate 1, 3. So I need to use this formula, which is going to be equal to root of x2 minus x1, 4 minus 1, which is 3, so 3 square, plus y2 minus y1, 5 minus 3, which is 2, so 2 square, which is root of 9 plus 4, which is root 13. So this distance PQ was root 13. Okay. Now sine theta, okay, is equal to 0.6. So what about theta? Sine inverse of 0.6, which is equal to, sine inverse of 0.6 is equal to 36.86 degree. Now see this. Theta is 36.86, alpha is 33.69. This is our line PQ. Okay, so this alpha, okay, this alpha is 33.69. Okay, 33.69. And now this line PQ is being rotated in clockwise direction. They given clearly it is rotated in clockwise direction by an amount of 36.86. Okay, so PQ is rotated by an amount of 36.86. So PQ will be rotated by an amount of 36 means what? This, like from here until I reach here, it's going to be 33 only. So from here I need to rotate it, it will reach somewhere here. So if I erase this and if I show you, this is going to look our new PQ. Okay, so our new PQ, this is how, not like this, somewhat like this. This is our new PQ dash. Okay, I'm going to take it as Q dash because that is our new Q, right? New coordinate. And what about this angle? Now I'm rotating it by an angle of theta. Okay, so I'm rotating PQ by an angle of theta, and this is alpha. Okay, this angle is alpha, angle between horizontal and PQ is alpha. So this new angle is going to be theta minus alpha. Okay, so let me show you the diagram again. This is our new PQ. Okay, so initially PQ was like this. I rotated it by theta angle. So now our new PQ is PQ dash, which I represented there. The angle initially between x dash and PQ was alpha, and I'm rotating it by theta. So the new angle, okay, the new angle will be theta minus alpha. So which is nothing but 36.86 minus 33.67, which is approximately 3.17 degree. Okay. Now how to find out this coordinate? Let me take it as x dash comma y dash. Okay, we need to find out the coordinates, right? So which means this distance x dash and this distance y dash. Okay, how can I do that? Very simple. Listen, this until this point, okay, until this point, what is the distance? Until this point, we know p is nothing but 1 comma 3, right? I erased it. P is nothing but 1 comma 3. So this distance was 1. Okay, I will show you in another color. This distance was 1. Okay, and what about this distance? This distance, how can I find? Simple. We know PQ dash. PQ dash value is what? PQ dash is root 13, right? Root 13. And if I resolve it in angle known side, understand carefully. PQ dash, I am resolving in angle known side. Angle known side is theta minus alpha, right? So if I resolve it in angle known side, this distance, I can determine this distance. Okay, I am highlighting it. Okay, this distance. I can easily find out this distance, and that distance will be nothing but this distance. So x dash is going to be equal to 1 plus PQ dash cos of theta minus alpha. So PQ dash is nothing but, let me first write it out, cos of theta minus alpha. Okay, and what about y dash? Y dash, simple. Again, y dash is also very easy. We know p, right? We know the p value. P is present at a distance. What is this distance? 3, which they given, right? Which they given 1 comma 3. P point is at a distance 3, 1 comma 3. Okay, so this is 3, and if I subtract this, distance, 3 minus this distance, okay, 3 minus that distance, then I can easily find out y dash, right? So y dash is nothing but this total minus this small distance. So total is 3 minus this small distance is what? Nothing but this, right? This small distance is nothing but this. So how can I find? Simply from the triangle. Okay, from this triangle, root 13, that is PQ dash, sine of theta minus alpha will give me, what is that? Will give me this distance. Okay, this particular distance. If I take what I'm going to take, okay, I will take it as x. Okay, so q dash x can be determined by multiplying root 13 with sine theta minus alpha. Okay, so 3 minus root 13, which is p dash q, sine, I'm very sorry, sine of theta minus alpha. So now the final answer is what? Instead of p dash q, I will write it as root 13 theta minus alpha. I will write it as 3.17. So finally I will be getting x dash and y dash if you solve it. So my answer is going to be 4.1, 4.6 and 2.8. Just pause the video and try to find out whether your answer is matching with my answer. So 4.6, 2.8, which is option A. Okay, let us do the next question. Okay, listen. A particle of unit mass. Okay, so there is a particle of unit mass. Unit mass means what? 1 kg is moving in a plane. Okay, it's a planar motion. Its trajectory in polar coordinates is given by r of t and theta of t. Okay, so they given r of t, that is r is given in terms of t time, that is time, I guess, time, yeah, t is a time, and theta t is going to be t. Okay, where t is given as time. Okay, the velocity of the particle at the time t is equal to 2 seconds is dash. So they're asking what is the velocity of the particle. So first of all, if I'm going to take it in the polar coordinate, what about our velocity vector? Is going to be Vr Er cap plus V theta Et cap, right? Where that Vr is nothing but r dot and V theta is nothing but r theta dot. Am I right? This is something which we got, okay, when I'm doing the polar coordinate derivation. Okay. Now first of all, r dot is what? That we already know. R dot is nothing but dr by dt. Okay, and theta dot is nothing but d theta by dt. Okay, so first Vr is going to be one time differentiation of this, so that is going to be 2t, which is equal to r. R is t square only into theta dot, so one time differentiation of theta, so that's going to be 1. Now I need to find both this velocity of the particle at a time t is equal to 2 seconds. So I need to find when time is 2. So finally, if I substitute 2 here, 2 into 2, which is going to 4. If I substitute 2 here, 2 square, which is going to be 4. So if suppose in some trajectory, this is the particle, okay, so from the origin we will be having two things, right? We'll be having two things. Let me just mark it like this, okay, two things. One is one is radial component, okay, that is VR. Another one is tangential component, that is VT, okay, VT, I'm sorry, I used to take it as VT or V theta, okay, I will take it as VT, tangential component VT, okay. And now I need to find out velocity of the particle, which is nothing but the resultant. So resultant of this 2 will be in this direction, which is V. So how to find out this? Very simple. V will be equal to root of Vt square plus Vr square, which is equal to Vt square is 4 square again plus 4 square, which is root of 32. Okay, so 16 into 2, so 4 root 2. Okay, so the correct answer will be 4 root 2 meter per second. Okay, right.